How are you doing today? Today, I'd like you to design a social media feed similar to Instagram or X. Imagine users can create posts, follow other users, and open their home feed to see recent posts from people they follow. As you design it, I'd like you to think about post creation, follow relationships, newsfeed generation, fan out on right versus fan out on read, caching, celebrity accounts. You don't need to jump immediately into the architecture. Start by asking me any clarifying questions you would normally ask an interviewer. Great question. Scale is very important for this problem. Assume, 500 million registered users, 200 million daily active users, hundreds of millions of posts per day. Most users follow a few hundred accounts. Some celebrities have tens of millions of followers. Also assume users expect their feed to load very quickly. What would you clarify next?
Should the feed be chronological or ranked?
Good clarification. For the first version, let's build a reverse chronological feed. If Alice follows Bob and Carol, Alice's feed could look like newest posts first. Later, we could replace chronological ordering with an ML-based ranking system. What are the main functional requirements you see?
Users should be able to create posts, follow and unfollow users, and view their feed.
Exactly. I would summarize the core APIs roughly like this. Post posts post users. I'd follow delete users. I'd follow get feed cursor equals. Now let's start with the data model. How would you store posts?
Maybe a post table.
Good. Something conceptually like post, post ID, author ID, content, media URL. Created it for very large scale. Post ID should usually be globally unique and roughly sortable by time. Media itself shouldn't normally live inside the database. Images and videos typically go into object storage, with the post containing references to those objects. Now let's think about followers. How would you represent Alice follows Bob?
Maybe a followers table with follower ID and followee ID.
Exactly. Follow, follower ID, followee ID. Created it. We might need efficient access in both directions. Who does Alice follow, who follows Bob? That second lookup becomes extremely important when we discuss fanout. Alice opens Instagram. How do we produce her feed?
Query all the people Alice follows, get their posts, sort them by time, and return the latest ones.
That's a perfectly reasonable first design. Followed users equals get following. Alice, posts equals get recent posts. Followed users, post sort. Created a desk. Return first 50. This approach is usually called fan out on read. Why do you think it's called that?
Because when the user reads a feed, we fetch posts from many accounts.
Exactly. The work happens when Alice requests her feed. Advantage. When Bob creates a post, creating that post is cheap. We don't immediately need to do anything for Bob's followers. But what is the downside? Exactly. Imagine Alice follows 1,000 people. Every feed request could require retrieving posts from many partitions, merging, sorting, and filtering them for hundreds of millions of users. That becomes expensive. So let's try the opposite approach. What if, when Bob creates a post, we immediately push that post into his followers' feeds?
That would make reading the feed faster.
Correct. This is fan out on right. Bob creates post P123 post service Q Alice John Sarah feeds. When Alice opens the app, the feed service can simply retrieve these post IDs and fetch the objects. Reads become extremely fast. For normal users, often yes, but there's a trap. Suppose Taylor Swift, or any huge celebrity, has 100 million followers. She posts hello. What happens if we use fan out on right?
We'd have to write that post into 100 million feeds.
Exactly. One tiny post causes 100 million feed writes. That's write amplification. Huge write bursts. Queue backlogs. Delayed delivery. So production social networks often use a hybrid architecture. Normal users. Fan out on write. Celebrity high fan out accounts. Fan out on read.
How do we decide who counts as a celebrity?
Excellent interview question. It's really a high fan out account, not famous person. A simple rule. Follower count. 100,000 fan out on write equals 100,000 fan out on read. Production can also consider posting frequency, active followers, and queue load. The insight. Don't let high degree nodes destroy your fan out infrastructure.
Where would Kafka come into this architecture?
Great question. Kafka, or another durable event log, sits between post creation and feed generation. 1. Store post. 2. Publish post created. 3. Return success. 4. Fan out workers process followers asynchronously. The post service shouldn't synchronously update thousands of feeds before replying to Bob.
What if the fan out worker crashes?
That's exactly why a durable queue is useful. The event remains available. Workers can retry. Make fan out idempotent so a post created event processed twice doesn't duplicate P123 analysis feed.
Where would Redis be used?
Redis is extremely useful here. The home feed is one of the hottest pieces of data in the entire system. We could cache post IDs in a sorted set. Key equals feed. User 123 score equals timestamp. Or later a ranking score. Value equals post ID. Then retrieving the latest feed entries becomes very fast.
Would we cache the whole post too?
Good question. Usually I'd separate two concepts. The feed cache stores post IDs. The post cache stores actual post objects. Feed retrieval. Redis feed cache. P31, P28, P22. Post cache hydrate feed response. This avoids duplicating the entire post object inside millions of user feeds.
What database would we use for post?
At this scale, the interviewer usually cares less about the exact product than about access patterns. Posts are mostly write post, get post by ID, get recent posts by author. A distributed NoSQL system such as Cassandra, DynamoDB, or ScyllaDB could work well. Partition key, author ID, sort key, created at. Watch for extremely active accounts creating hot partitions. Time buckets like author ID, month, help.
What about pagination?
Great. Avoid offset pagination for a feed this large. Get feed offset equals 10,000 becomes inefficient while new posts are arriving. Use cursor-based pagination. Get feed limit equals 20 posts. Next cursor. 1,723,809,000 P877. Get feed limit equals 20 and cursor equals 1,723,809,000 P877. The cursor means continue after this feed position. That works much better for continuously changing datasets. Nice edge case. Suppose Alice unfollows Bob. We could eagerly remove Bob's posts from Alice's materialized feed. That may require scanning and deleting. Another common strategy is lazy filtering. When Alice reads, skip posts whose author she no longer follows. Background jobs gradually clean stale entries. The same idea applies to blocked users, deleted posts, private accounts, and moderated content. The feed layer often performs a final eligibility filter. Another good question. We don't have to immediately remove that post ID from millions of cached feeds. The post service can mark P123 as deleted. When feed service hydrates, the lookup returns deleted unavailable and we skip it. An asynchronous cleanup process can later remove stale references. Again, we avoid massive synchronous distributed cleanup. I'd describe it like this in an interview. Client's API gateway post service, follow service, feed service, post DB plus Kafka fanout workers normal user feed caches, redis, follow DB for the graph, redis for the hot home feed, normal user, create post DB Kafka fanout into follower caches, celebrity, create post, store it, no massive fanout, on red. Materialized feed plus celebrity posts merge filter sort hydrate return. Nice work, you covered the core idea. One follow-up, what fails at 10x traffic, and how would you measure it? We can keep going or end here. This one, fan out on write, expensive writes. Cheap reads, best when most users have manageable follower counts. Reads greatly exceed post creation, and low feed latency matters. Fan out on red, cheap writes, expensive reads. Best when accounts have enormous follower counts and pre-computing millions of feeds is impractical. Hybrid, normal accounts fan out on write, celebrity accounts fan out on red. That's usually the strongest answer.